Hello everyone. Good evening.
Good evening, sir.
Yeah, good evening.
Good
Everyone.
evening, sir.
Good evening. Shall we start our class?
Yes, sir. Yes, sir.
Okay. Yeah. Today we are going to start one of the important DevOps tools, that is Git. Okay. Git. I have PPT for that, guys. Let me just open it up. Just 1 minute. Okay, fine. Yeah. See, as I said, Git is one of the most important DevOps tools. Okay. That's why we are starting with Git. Okay. So before you understand Git, you must know an important word, that is source code management. Okay. Source code management. See guys, now I'm not talking about Git. I'm talking about source code management. Okay. I'm repeating. I'm not talking about Git. I'm talking about source code management. SCM. So what is source code management? Simple. Managing the source code. Source code means whoever writes a code, whatever code is it. If you write any code, that is going to be your source code. If I write any code, that is going to be my source code. Any code. Adding that code, editing that one, deleting that one, that is what we call management. That means source code management is a storage. It is just a storage where we store our code. Apart from storing the code, we can manage. We can add some more code, we can delete, we can edit, we can do everything in that one, all management activities. That is what source code management. It is just a storage. Now, who uses this storage? Everyone, whoever deals with the code. Like developers, yes, they do write the code to create any application. So they need source code management. Testing team, they write some test cases, that also in the form of code only. So they also need source code management, this storage. DevOps units, yes, we are going to write some scripts. What scripts we are going to write, that we are going to learn in other tools, Ansible and all. So that means we are also going to deal with the code, scripting language and all. So that we are going to store here. That means whoever write the code, whoever deals with the code in companies, all they need source code management. Don't think that only developers. No, we also deal with the code. Remember that. So they need, all of us, we need this storage. Apart from storing the code, we can add, delete, edit, everything. That's what management. Different people from different teams can store simultaneously. It saves all changes separately. That means here this is storage. Different teams, different people from different teams, any number of teams, they can store code. Each and every code will be stored separately. Each and everyone's code. Okay, so different people from different teams can store simultaneously. It saves all changes separately. Bank is there. Anyone can create their account. Anyone can save their money. It doesn't mean that your money is getting overlapped with mine. Nothing, right? We have everyone has their own different accounts. So there is no confusion. There is no overlap. Correct. So here also everyone's code will be stored separately. Okay. It acts like a pipeline between offshore and onshore teams. Pipeline in the sense, see, this is Indian team. This is USC. So we both working in one project. Now Indian team, So see what they have written 10% of code. They want to create one application. So for that 100% code should be written. So in that they have written 10%. So after finishing the code, they store the code in source code management. Okay, morning till evening they have written. So once we finish our work, USA guys, they start their work, correct? For us, it is, once we finish our work, like 8 p.m. and all, USA guys, for them 10 a.m., correct? So they start. Before they start, they take existing code. On top of that, they will add some more code. Then again, they push. Now it became 20. When we start our work, we take that extra, that one, then we add 10 more percent, then we push. Then US guys, again, they take that. That means, see, even though our geographical locations are different, we are working like a team, correct? We are working like a team, right? And it is acting like a pipeline. See, we are pushing, they are pulling, they are pushing, we are pulling. So it acts like a pipeline between offshore and onshore teams and helps in achieving teamwork. Okay, that is so. And track changes at minute level. See, suppose if your intention is to manipulate that code, suppose you want to delete some code, you delete it and you think that no one will come to know. No. Out of 1 lakh lines, 1 lakh, even if you add any small dot, or even if you delete any small dot, that will be in the knowledge of everyone. Everyone will come to know. That means you cannot manipulate the data. Okay, so it tracks changes at minute level. If you add something, that will be in everyone will come to that. Yes, someone adds something. That's all. Okay, so this is what source code management. It is just a storage where we store our code. Now this one we can achieve by using either of these tools. Okay, so these you can use Git, SCM, Perforce, Clear Case. That's why we call these tools as SCM tools. Simple guys. Cloud is a concept. This you can achieve either by using AWS or Microsoft Azure or GCP. Bike is a concept. If you want bike, either you can buy Pulsar, you can buy KTM, you can buy Scooty, correct? So here also source code management is a concept. This you can achieve either by using Git or SVN, Perforce, Clear Case. Out of these, SVN means subversion. The most advanced tool is Git. That's why we are using Git, most advanced tool. So Git we call source code management tools. It is one of the source code management tools. That means Git is a storage where we store our code. Apart from storing the code, we can manage that code, okay, by using Git, right? Okay, so now let me show you the architecture of Git. Okay, now I'll draw roughly. Later on, I will draw properly with tools. Then I will share that pic. Okay, let me draw this one. Okay. Fine. See here. So let me take an example. Assume that 2 guys are working. One is Mr. Sai. Another one is Mr. Hari. Assume 2 guys are working. Now what I do? Okay, Sai is from Mumbai. Just assume. Hari is from London. We both working in one project. So what we do first, we are going to launch one EC2 instance. Okay, I'm going to launch one EC2. Hari also is going to launch one EC2 instance. Okay. After launching these instances, we go inside that instances and we install Git. We install install Git -5. Just we install. After installing Git, we can run Git related commands, correct? Yeah. So what we are going to do, first what Sai is going to do, Sai is going to create one directory. Okay, see, Sai is going to just create one directory. You can give any name. Okay, Mumbai Git, assume. I'm giving a name called Mumbai Git. Okay, this is just a directory. Let me write here better. Okay. Mumbai Git. After creating directory, it is just a directory. Then I go inside the directory, I'll run one command called git init. Git init means initializing Git. See, I have launched one EC2 instance. Then I install Git. Then I create one directory. Then inside the directory, I'll run one command called git init. When I run that command, that directory will be converted into Git repository. After running this command, that normal directory will be converted into Git repository. So Git repository means what actually happens? In that 3 stages will be created automatically. One we call workspace. Second we call staging area. Either you can call stage or you can call index. Third we call local repository. And inside local repository, there will be one branch. By default, the name of the branch is going to be me. I'll tell you what is the branch and all, don't worry. So after running this command git init, all 3 stages will be created: workspace, staging area, local repository. In that local repository, one branch will be created called me. It happens automatically. Now, what Sai is going to do? Sai is going to create one file in workspace. Okay, one file. Let's give any name. Okay, test file. Later on, I'll draw this diagram properly, guys. Okay. As of now, just know. So Sai is going to create one file and he will write some code. Okay, assume that he has written this code, lot of code from morning till evening. After writing code, before he leaves his office, he is going to add. When he runs this add command, automatically that file will go to staging area. It's a copy and paste. It will go to staging area. After adding, he is going to commit. So when he commits, automatically that file will come here. Okay, automatically that file will come here. So he's going to add, he's going to commit. Whenever he commits, he'll get one ID called commit ID. That is just an identification ID. Okay, every time you do a bank transaction, you'll get one transaction difference ID. So same thing. Okay. Then the team lead. See, Sai Hari is there. They have one team lead. The team lead, what he is going to do? He will go to one website called GitHub. He'll go to one website called GitHub. GitHub is a website. In that, he will create one account. Let me show you. See. This is GitHub. Okay, he will create one account. In that, he will create one repository. Assume that local repo. Any repo. Okay, you can give any name to that repo. Assume that I'm giving a central repo. Repo means storage. Okay. Now, what is GitHub, guys? GitHub is an online storage, belongs to Microsoft company. You can just, compare with Google Drive. Google Drive. So Google Drive belongs to Google company, GitHub belongs to Microsoft company. Okay, so Google Drive, to access storage, you need to have Google account. Here also you need to create GitHub account. After creating Google Drive, you can create some directories. So in the same manner, in GitHub, we create repositories. In the directories Google Drive, we store some data, right? Anything. Here also in that repository, you can store some data, right? It is just a kind of Google Drive, right? So here, the entire concept we call Git. This is just an online storage called GitHub. Okay. So in place of GitHub, you can use Bitbucket. Bitbucket belongs to some other company, Atlassian company. Okay. In place of that, we can use GitLab. Like many storages are there, either GitHub. This is what central storage. Okay, GitHub, Bitbucket. We can use Bitbucket also. So this entire concept we call Git. Don't think that Git and GitHub. GitHub is just online storage. In place of that, we can use Bitbucket also. You take any central repository. You can take central repository of any, either GitHub or Bitbucket, anywhere. But we need to have one central repo. So the entire concept we call Git. Entire concept. Okay. So GitHub is a popular one. That's why we take GitHub. From that team lead, he will create one repository called central repository. Then see, I have added some data, I have committed. Then I'll push this one to central repository. Push. When I push, automatically that file will go to central repository. That's all. That means whole day I work from morning till night. Before I leave my office, I'll do three things. I'll add, I'll commit, I'll push. Okay, Git is all about these three things. Add, commit, push. Just remember these. Add means sending that file from workspace to staging area. Commit means sending that file, the copy of the file from staging area to local repo inside branch. Pushing means from local repository to central repository. That's it. I have done my work. Then I finish my work, right? So Hari will start his work. So what Hari is going to do? Hari launched one EC2 instance already. Then he will create one directory. Let's take the directory name as London Git, assume. Then he will go inside the directory, he will run git init command. When he runs git init, automatically same, that folder will be divided into 3 stages. Now Hari is not going to write code from the scratch. Hari is going to take existing code first. He is going to pull. When he pulls, automatically that file will come here. Workspace. Then automatically that will come to staging area. Automatically that will come to local repo. Inside branch. Automatically. So with one single pull command, that file will come to all 3 stages automatically along with the data. Then this, Hari is going to add some more data. After adding, he will add. Then he will commit. Then he will push. Immediately that extra data will come here, extra. Whatever just red color is here. Then Sai is going to pull. Once he finishes his work, next day morning, Sai will start his work. Before he starts, he is going to pull. Okay. When he pulls, automatically that data will come here, here, here. Then Sai will add some more data. Then he will add, then he will commit. Then when he pushes, that extra data only will go there. Then Hari will pull the data. Will add some more data, will commit and will push. So this is how it is going to be. The workflow is going to be. Okay, adding, committing, pushing. So other guy, he will pull that one. Then he will add some more data, commit pen, then he push. So it's all about, mainly Git is all about 5 words. Add, commit, okay, push, pull. Yeah, only 4 things. Add, commit, push, pull. This is the main thing. Okay, that is how we are going to do it. Right? This is how it is going to work. Yeah, fine. I mean, here we are going to add many more things slowly, one by one. But just as of now, just remember this much. As of now. Okay, fine. Now, let's try to understand the key terms, terminology. First one, repository or depot. Repository or depot. Repository means That could be local repository, could be central repository. And one more thing I see, local repository means either only this stage or the entire directory also we can call local repository. Either you can call this portion as local repository or entire Mumbai Git folder itself also we can call local repository. That means, see, simple. When you talk in a bigger sense, like, hey, local repository, central repository, when you compare local with central, central means the central repository, local means this entire folder. But when you say workspace, staging area, local, that time refers to this one. That means actually workspace and staging area also part of local repository. These are the subsections of local repository. So that's why when we compare local versus central, I am referring to whole folder. Local repository means the entire Mumbai Git folder. Central means this one. But when I say workspace, staging area, local, that means, yes, these are three different things. Based upon the situation, generally we use. So here they are saying repository or depot. So means in Git we call repository. In other tools we use a word called depot. So repository could be local repository, could be central repository. That's up to you. I mean, that depends. Okay. Server means are EC2 instances. EC2 instances we call servers, in which we create local repositories. Got it? Workspace, work directory, work tree. These are place where you work. You can say I created file. Either you can call workspace, work tree, or work directory. That's up to you. These are place where you create files, where you work. See, you are creating file in workspace, you are putting some code in workspace. After that, just you are adding, committing, and pushing. So you are not editing that file in staging area, local repository, and central repository. No. Where you are working physically, where you are editing that file, adding data and all workspace. Correct? That's what we call workspace, where you work. Branch, trunk, code line. In Git, we use a word called branch. In SVN, we use a word called trunk. In some other tools, we use a word called code line. So branch means every local repository will have one branch. Earlier, that name used to be master. Earlier, long back, but recently they changed that one. Now that default name is main. So here, when you commit, that file will be stored inside branch only. Inside branch. Say, when you go to bank, you don't dump money in the bank, right? You create one account. In that account only, you keep money. Here also same thing. We store that code in local repository inside branch only. Inside branch, right? Yeah. Commit, check-in. In Git, we use a word called commit. In other tools, we use the word check-in. Commit means sending that file from staging area to local repository. That process we call commit. So every time you commit, you'll get one ID, just like a transaction reference ID, right? Here also, that ID will be generated. That ID only, either you can call version or version ID or commit ID. That ID is right. That we call either version ID or commit ID. Tag is what? See, this commit ID contains 40 long alphanumeric characters. 40 long alphanumeric characters. Since we can't remember that tag, that commit ID, that's why we can assign a tag to this commit ID. See, we can't remember transaction reference ID. That's why when we do any transaction, we give some remarks. Why are we doing this? Like, for example, phone number we can't remember. That's why we are saving phone number with some name. That name is tag. So we are assigning a tag to that commit ID so that we can remember that ID easily. Tag is just a name, right? Yeah. So these are the general terms that we use. Okay. Yeah, just elaborated explanation. Repository means storage. That could be, that's just a folder. Okay. Server EC2 instance, right? Server means where we store repositories, correct? In instance, the server, inside we are keeping one repository.